Derivatives of trigonometric functions. Sine and cosine. Let's begin by looking at a couple of animations. Here we see the graph of sine x between minus 2 pi and 2 pi. The animation will plot the slope of that graph. Notice that the graph of the slope looks exactly like the graph of y equals cosine x. Now let's do the same thing with the cosine function. The blue graph will be the graph of the slope of y equals cosine x. Here the graph of the slope looks just like the graph of minus sine x. So these two plots suggest that the derivative of sine x is cosine x, and that the derivative of cosine x is minus sine x. Now let's see if we're right about that. Let f of x equal sine x. The definition of the derivative says that f prime of x is the limit as h goes to 0 of sine x plus h minus sine x divided by h. Using the addition formula for sine, we rewrite sine of x plus h as sine of x times cosine h plus cosine x times sine h. Now we factor sine x from the first and last terms in the numerator, break the fraction up into two terms, and then bring sine x and cosine x outside of the limits since those factors are independent of h. But now we notice two familiar limits. The limit as h goes to 0 of cosine h minus 1 over h, we recall, equals 0. And the limit as h goes to 0 of sine h over h, we'll recall, equals 1. So the derivative of sine x turns out, in fact, to be cosine x. Now let's look at cosine x. Using the definition of the derivative, f prime of x will be the limit as h goes to 0 of cosine x plus h minus cosine x divided by h. Using the addition formula for cosine, we write cosine x plus h as cosine x times cosine h minus sine x times sine h. Now we factor cosine x from the first and last terms in the numerator, break the quotient up into two terms, bring cosine x outside the first limit and sine x outside the second limits, and so now we have the very same two basic limits that we just saw when we computed the derivative of sine x. So the derivative of cosine x is cosine x times 0 minus sine x times 1, or minus sine x. So we've now learned that the derivative of sine x is cosine x, and the derivative of cosine x is minus sine x. Example: let f of x equal 3 times cosine x minus 2 times sine x. Find f prime of x. F prime of x will equal 3 times the derivative of cosine x, which is minus sine x, minus 2 times the derivative of sine x, which is cosine x. And so f prime of x is minus 3 sine x minus 2 cosine x. Another example: let y of t equal sine t times cosine t. Let's find y prime of t. We'll use the product rule. The derivative of the first factor sine t is cosine t, which we multiply by the second factor, and then add sine t times the derivative of cosine t, which is minus sine t. So we have cosine squared t minus sine squared t, which you may recognize as being the same as cosine 2t. Example: let g of theta equal cosine theta divided by 1 plus sine theta. Let's find and simplify g prime of theta. Here we'll use the quotient rule. The denominator will be 1 plus sine theta squared. To get the numerator, we write the derivative of cosine theta, which is minus sine theta, times the denominator 1 plus sine theta, minus the numerator cosine theta, times the derivative of 1 plus sine theta, which is 0 plus cosine theta. Now we rewrite the numerator as minus sine theta minus sine squared theta minus cosine squared theta. And we notice that minus sine squared theta minus cosine squared theta is equal to negative 1. Next we'll factor out a minus 1, and then cancel a factor of 1 plus sine theta, and end up with minus 1 over 1 plus sine theta. The other trig functions. Let's look at the tangent function. Let f of x equal tangent x. This is the same as sine x over cosine x, so we can use the quotient rule to calculate f prime of x. The denominator will be cosine squared x. The numerator will be the derivative of sine x, or cosine x, times cosine x, minus the numerator sine x times the derivative of the denominator cosine x, which is negative sine x. We simplify the numerator and get cosine squared x plus sine squared x, which is 1. And so we have 1 over cosine squared x, or secant squared x. Now let's look at cotangent. Since cotangent x is the same as cosine x over sine x, we can again use the quotient rule to compute its derivative. The denominator will be sine squared x. The numerator will be the derivative of cosine x, which is minus sine x, times sine x, minus the numerator cosine x times the derivative of the denominator sine x, which is cosine x. So here we have minus sine squared x minus cosine squared x over sine squared x. The numerator here is negative 1, so we have minus 1 over sine squared x, which is the same as minus cosecant squared x. Now let's look at secant x. Secant x is the same as 1 over cosine x, and to compute the derivative we'll use the reciprocal rule. We have minus 1 over cosine squared x times the derivative of cosine x, which is minus sine x. Now we'll rewrite this as 1 over cosine x times sine x over cosine x, and recognize that this is the same as secant x times tangent x. Now finally, the cosecant function. Cosecant x is the same as 1 over sine x, so again we'll use the reciprocal rule. Our denominator will be sine squared x. The numerator will be minus the derivative of sine x. We write this as minus 1 over sine x times cosine x over sine x, and recognize that may be written as minus cosecant x times cotangent x. To summarize, we've just learned that the derivative of sine x is cosine x. The derivative of cosine x is minus sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is minus cosecant squared x. The derivative of secant x is secant x times tangent x. And the derivative of cosecant x is minus cosecant x times cotangent x. Now notice that there's a bit of a pattern here. In fact, if f is any one of these 6 functions, then the derivative of the cofunction of f is the negative of the cofunction of f prime. So if you remember this, you really only need to remember 3 derivatives. For instance, if you know that the derivative of tangent x is secant squared x, then you also know that the derivative of cotangent x is minus cosecant squared x. Another example. Let's let f of x equal secant x times tangent x. Let's find and simplify f prime of x. We'll use the product rule. The derivative of secant x is secant x times tangent x, so we multiply that by the second factor tangent x, and add the first factor secant x times the derivative of tangent x, which is secant squared x. Now let's factor secant x from both terms, and write this as secant x times tangent squared x plus secant squared x. Another example. Let f of x equal secant x divided by 1 plus tangent x. Let's find and simplify the derivative. Here we'll use the quotient rule. The denominator will be 1 plus tangent x squared. The numerator will be the derivative of secant x, which is secant x times tangent x, times the denominator 1 plus tangent x, minus the numerator secant x times the derivative of the denominator, which is 0 plus secant squared x. Now we rewrite the numerator as follows, factoring out a secant x. And notice that we have tangent squared x minus secant squared x in the second factor. Now since tangent squared x plus 1 is equal to secant squared x, tangent squared x minus secant squared x is negative 1. So we can rewrite our result as secant x times tangent x minus 1 divided by 1 plus tangent x squared.